We've looked at using area to find the amount of space under the curve. Now we're going to translate this into volume. So how do we use that concept to find volume? Well, if we took that area that we just had and now rotated it or revolved it around an axis such as the x-axis, that would carve out a solid that has cross sections that are these circular discs that are the shape of a cylinder. So if we took and figured out all those cylinders from one side to the other, we should be able to find the total volume of this. So how do we find area of one of these discs or cylinders? Well, we would need the area of this shape, which it's kind of skewed there, but it's a circle. And we know area is pi r squared for a circle. And then we'd multiply it by whatever that height would be for that. That's how you find volume of a cylinder. Well, in our case, our height here is our change in x, and our radius is our would be our y value here, or another way of writing our y value would be our function. So our radius ends up being our function squared times pi. So that would give us our the volume of one of these. If we want the volume of all those disks, then we need an integral to find those, and it'd be the integral from wherever we're starting to wherever we're ending. So that's the concept of doing this. When you integrate the area of all these disks over an interval from A to B, we're integrating the area of that circle times the height, which is the volume, and we're doing that volume from one side to another to get all the disks, and so we end up with this volume equation. So that's the equation that we want to use to find volume when we're rotating. So let's look at an example problem. Find the volume obtained by rotating about the x-axis, the region under the curve of square root of x from 0 to 1. Illustrate the definition of volume by sketching it. Well, we got the volume sketched out here, and we know what it's going to look like revolved. We've seen the pictures in the last few slides here. So let's write out our integral from 0 to 1 of pi times the radius. Well, our radius, no matter where we are, is going to be the y value that comes from taking square root of whatever the x value is. So square root of x is our radius squared, pi r squared, times the height, and the height of this is going to be, of each of those cylinders, is dx. So if we integrate that, that should give us our volume. This one's not too hard to do. Simplifying, what we're going to do, pi is just actually a constant. Let's pull that out. Square root of x squared is just x. So integrating that now, be 1/2 x squared evaluated at 1 and 0. If we put 1 into that, it's 1 squared is 1 times 1/2 is 1/2. Minus, if we put 0 in there, it's just 0. So it looks like we get 1/2 pi, or we could also write that as pi over 2. And it would be whatever these units are cubed. So volume is rotating around when rotating around the axis, is pi times the function squared to get that.